Hello everyone, I am Shivam Agarwal. I got selected in IIT JEE 209 with an All India rank of 27 and I secured an All India rank of 56 in IIEEE and I passed my board examination with a percentage of 93.2%. And today I'll be going on with the advanced problems in 3D geometry. So I start with the first problem. Okay, so the first problem is that at the origin there is a mirror and there is a source of light somewhere along the x-axis. Somewhere along x-axis there is a source of light normal to the mirror, has direction ratios 1, -1 and 1. Find direction cosines of reflected ray. The options are 1/3, 2/3, 2/3, -1/3, 2/3, 2/3, -1/3, -2/3, -2/3, and fourth is -1/3, -2/3 and 2/3. I once again repeat the question that I have a source of light somewhere along the x-axis. There is a mirror placed at the origin and a light ray is incident from the source of light to the mirror, and the normal to the mirror has direction ratios 1, -1 and 1. We have to find the direction cosines of the reflected ray. So here we go. This is the image. So this is say source of light S, this is the mirror M, and normal to the mirror is somewhere along this. It's in 3D, it's coming out. Now the light ray is incident this, so this is the angle of incidence and we have to find the direction cosines of the reflected ray. Okay, so basically we know that this is the incident ray, this is the reflected ray. The normal is basically the internal bisector of the incident ray and the reflected ray. Here I have used two most important properties of reflection of light, that is the angle of incidence is equal to angle of reflection plus the normal, the incident ray and the reflected ray all are in the same plane. So if I use this notion that the incident ray and reflected ray, the internal bisector of both these rays is the normal, then I have used both these concepts. So say the direction cosines of this reflected ray are LMN. Say L, M, N are direction cosines of reflected ray. Direction cosines of incident ray. I'll take, since the incident ray is towards the origin, but to find the internal bisector, I will assume this as my incident ray and this as my reflected ray. So direction ratios of incident ray are this. Since it is along the x-axis, these are direction ratios, not direction cosines of incident ray. So normal direction ratios of normal are the direction ratios of the internal bisector of two lines is the sum of their direction ratios. It's L plus 1, M and N. These are direction ratios of the normal and these are also direction ratios of the normal, so these two should be proportional to each other. So L plus 1 divided by 1 should be equals to M divided by -1 should be equals to N divided by 1. So this is what I get. Now we know that L square plus M square plus n square is equals to 1. Therefore L square, m we can write in terms of L as minus, m is minus 1 into L plus 1. So this is again L plus 1 whole square. N is L plus 1, so this is again L plus 1 whole square is 1. So therefore it's 3L square plus, this is L square plus 2 is 4 plus 2L plus 2L is 4L is equal to 1. So 3L square plus 4L plus 3 is 0. So L is minus 4 plus minus 16. I think I've done a mistake. L plus 1, this is I cap, this is this. Direction ratios are 1, minus 1 and 1. L plus 1. So L plus 1 divided by 1 is m divided by minus 1 is equal to n divided by minus 1. So m is minus 1, L plus 1, L square plus m square plus n square, that is L square plus 2, oh I'm sorry, here it should not be 4, it should be 2. So it's this is L square plus 2L plus 1, this is L square plus 2L plus 1, so this gives 3L square plus 4L plus 2 is 1, so 3L square plus 4L plus 1, so L is minus 4 plus minus b square minus 4ac, this is 12 divided by 2a, this is 6, so this gives minus 4 plus minus 16 minus 12 is 4, under root is 2 divided by 6, so this is minus 4 minus 2 minus 1, or minus 4 plus 2, minus 4 plus 2 is minus 2 divided by, or minus 1 by 3. So this is what I get as my L. Okay, so if now m is minus 1 minus times L plus 1, so if L is minus 1 then it is 0, or if L is minus 1 by 3 then it is minus 1 by 3 plus 1, that is plus 2 by 3 minus 2 by 3, and n is L plus 1, if L is minus 1 it is 0, or it is minus 1 by 3 it is 2 by 3. So I get two answers, minus 1 comma 0 comma 0 and minus 1 by 3 comma minus 2 by 3 2 by 3. Now minus 1 comma 0 is the direction cosines of the line which is along the x-axis only, and that is my incident ray, so it cannot be my reflected ray. So the direction cosines of my reflected ray are minus 1 by 3, minus 2 by 3 and 2 by 3, which is this. Okay, so this was about reflected ray and incident ray. This question has been covered in IIT JEE as well. Now let's move on to second question. Second question says that find the minimum value of x square plus y square plus z square when ax plus by plus cz is equals to p. Options are, first is p upon summation a, second is p square upon summation a square, third is summation a square upon p, and fourth is 0. Fine. So this is, as it seems as a completely algebraic question, but it is quite difficult if we try to do it without knowing the applications of 3D geometry. So as we can see directly that this is a plane ax plus by plus cz equals to p. So let's write it in a proper format. Let's divide it. Now this is the equation of a plane in a format when a upon summation a square, b upon summation a square, c upon summation a square are respectively the direction cosines of the normal to this plane. And we know that the equation of this form Lx plus my plus nz equals to p, yes, say d. In this equation, if L, M and N are the direction cosines of the normal to this plane, then d is the distance of this plane from the origin, perpendicular distance of this plane from the origin. And see this thing, x square plus y square plus z square. This is the distance of the origin from any point on this plane. So consider this plane. This is our origin. So these are all possible values of x square plus y square plus z square, and x square plus y square plus z square will be minimum when this distance will be perpendicular to the plane. We can directly see from Pythagoras theorem that x square plus y square plus z square, there is distance of any point from this origin will be minimum when the line joining that point and the origin is perpendicular to this plane. So the minimum distance, that is x square plus y square plus z square, this is under root. So this is the distance of the origin from a point will be minimum, and that minimum distance will be equal to this perpendicular distance. So x square plus y square plus z square is p square upon summation a square. Now let's move on to question number 3. There is a tetrahedron made by 3 coordinate planes, and a variable plane. Volume of tetrahedron is fixed 64 kq. Find the locus of centroid of tetrahedron. So I once again repeat the question. We have a tetrahedron formed by 4 planes. The 3 planes are the coordinate planes, that is xy plane, yz plane and xz plane, and there is also a variable plane. The volume of this tetrahedron is fixed, which is equal to 64 k3. We have to find the locus of centroid of tetrahedron. So how we will proceed? So let the variable plane be P, that is Lx plus My plus Nz equals to P. This is our variable plane. The other 3 planes are x equals to 0, y equals to 0 and z equals to 0. So this is our tetrahedron, say. So this is the, so let us find the 4 vertices of this tetrahedron. To find 4 vertices, we will take 3 planes simultaneously. So let us take x equals to 0, y equals to 0, z equals to 0. So one point we get is 0, 0, 0. Now let us take this plane and these two planes. So one point we get is x equals to 0, y equals to 0, so z is p by n. Similarly we get 0 comma p by m comma 0. Similarly p by l comma 0 comma 0. So these are 4 points of 4 vertices of our tetrahedron. Now the volume of this tetrahedron is 1 by 6 box these vectors as we studied in vectors. So volume is 1 by 6 the determinant of this vector, this vector, this vector. So this vector is 0 0 p by n, that is 0 p by m 0, and that is p by l 0 0, which is equals to 1 by 6 times p by n, and that is the complete modulus of this. So this is 1 by 6 p by n, and when we take the modulus, it is p square by ml whole mod, p square by ml. So this is 1 by 6 p by n, p by m, p by l mod is 64 k cube. Okay, so this is the volume, and let us find the centroid. So centroid is sum of the x coordinates of all its 4 points divided by 4. So this plus this plus this plus this, so this is p by 4l, similarly p by 4m and p by 4n. So to get the locus, x is replaced by this, y is replaced by this is replaced by x, this is replaced by y, this is replaced by z. So what I get is so we have p by m, p by l and p by n is equals to 64 into 6 k cube. So this is p by l is 4x, this is 4y, this is 4z, is 64 into 6 k cube mod, this is also mod, so x, y, z mod is 6 k cube. So this is the answer. Okay, so now let's move on to question number 4. We have two lines L1 and L2 are two skew lines. Show that P and Q are points on L1 and R and S are points on L2. Show that PR is not parallel to QS. So we have two skew lines L1 and L2. The basic property of skew lines is that they are neither parallel nor are they coplanar. Okay, so we have two skew lines and we have to show that for any 2 points P and Q on line L1 and any 2 points R and S on line L2, PR cannot be parallel to QS. So how do we proceed? So let's say that line L1 is, R vector is A plus lambda b, and say L2 is R is say C plus lambda d. Fine. So now let's say P is R is A plus lambda 1 b, Q is R is A plus lambda 2 b, R is C plus, this is say mu 1 d, and S is C plus mu 2 d. So these are the 4 points. So we are saying we have to show that P, R and QS are not parallel. Okay. So since these two are straight, since these two are skew lines, so these two lines are not in the same plane. So if we have two lines, so this is one line A vector and along B vector, this is a line C vector and along D vector, so this is the vector A minus C. So these three vectors cannot be coplanar. So B vector, A minus C vector and D vector, these three vectors are not coplanar. So these three vectors form a set of linearly independent vectors. Fine. So if PR is parallel, so let's find the direction along PR. So this is A minus C plus lambda 1 b minus mu 1 d, and let's find along QS, that is A minus C plus lambda 2 b minus mu 2 d. Okay, so if PR is parallel to QS, then this vector is some say gamma times this vector. So then A minus C plus lambda 1 b minus mu 1 d is some gamma times A minus C plus lambda 2 b minus mu 2 d. So this gives A minus C 1 minus gamma plus B lambda 1 minus gamma lambda 2 plus D gamma mu 2 minus mu 1 is 0. Now we know that A minus C, B and D are three non-coplanar vectors. That is, those three vectors form a set of linearly independent vectors. So we studied earlier that equation of this form, when these three vectors are linearly independent, then the coefficients should all be 0. So 1 minus gamma is 0, therefore gamma is 1. Lambda 1 minus gamma lambda 2 should be 0, since gamma is 1, so lambda 1 is equals to lambda 2. Similarly, mu 1 is equals to mu 2. So if lambda 1 is lambda 2, then P is equals to Q and R is equals to S, and so we cannot get we cannot get PQ is parallel to RS. PR is parallel to QS. I'm sorry. Okay, so now let's move on to question number 5. So this question states that a line with direction ratios 2, 7, minus 5 is drawn to intersect the lines x minus 5 by 3 is y minus 7 by minus 1 is equals to z plus 2 by 1 and x plus 3 by minus 3 equals to y minus 3 by 2 equals to z minus 6 by 4. Find length intercepted. Okay, fine. So a line where direction ratios 2, 7, minus 5 is drawn to intersect these two lines. We have to find the length intercepted. So let's say this is line L1 and this is line L2. So any point on line L1 is 3r plus 5 minus r plus 7 and r minus 2, and any point on line L2 is minus 3t minus 3, 2t plus 3, 4t plus 6. R and t are parameters. So let this line intercept L1 at this point, L2 at this point for a particular value of r and t, and now the direction ratios of this line will be proportional to 2, 7, minus 5. So minus 3t minus 3 minus 3r minus 5 divided by 2 is 2t plus 3 plus r minus 7 divided by 7 is 4t plus 6 minus r plus 2 divided by minus 5. So let's solve them. Let's solve these two equations. What I get is minus 21t, that is minus 8, 7 8s are 56, minus 21r is equals to 4t plus 2r, that is minus 4, that is minus 8. So this is what we get is 4 and 21 is 25t, 2 and 21 is 23r, 56 8 is 64 is 0. Now let's solve these two equations. So by solving these two we get minus 10t minus 5r, that is minus 4 minus 5 is 20, is 28t minus 7r, 6 plus 2 8 is plus 56. So this is what we get is 38t, that is plus 5 minus 7 minus 2r, and that is 36 is 0. So this is 19t minus r plus 18 is 0. Okay, so if we solve these two equations, what we get is so let's rewrite these two equations. So these two equations are 25t plus 23r plus 64 is 0, equation first, and 19t minus r plus 18 is 0, equation second. Now let's solve them. It's 25t plus 23. Now r is 19t plus 18 plus 64 is 0. So I get 25t plus 23 into 19, It's 437 plus 23 into 18 is 414 plus 64 is 0. So this is 5 plus 7 is 12, 1. 3 and 4 is 7. Sorry, 3 and 3 is 6. So this is 462t plus 4 and 4 is 8. 7, 478 is 0. So I get t is minus 478 divided by 462. Using this value of t and putting in this equation, we can find r. Once we have t and r, we can put in these two lines, we will get the point of interception, and then we can find the length intercepted. I'm not doing it since the calculations are too complex. So the main part, the main crux of this question was still here, and now it is easy to do. Okay, so now let's move on to question number 6. So we have to find the distance of the point (3, 8, 2) from the line x minus 1 by 2 equals to y minus 3 by 4 equal to z minus 2 by 3 measured parallel to the plane 3x plus 2y minus 2z plus 15 is 0. So I once again repeat the question that I have to find the distance of from the point P to this line, which is measured parallel to this plane. So if this is the line, this is the plane, this is point P, so I have to measure this which is parallel to this plane. So what I mean by is, so since this is the line, any point on this line, say Q on line L is 2t plus 1, 4t plus 3 and 3t plus 2, where t is a parameter. Now this is any point on this line, and this is point P which is 3, 8. This is point P which is 3, 8, 2, and this is point Q. Now this line PQ is parallel to the plane, so PQ is perpendicular to normal to the plane. So normal to the plane is direction ratios 3, 2, minus 2. So PQ direction ratios of PQ are this minus 3, so 2t plus 1 minus 3 is minus 2, 4t plus 3 minus 8 is 4t minus 5, 3t plus 2 minus 2 is 3t. Now this is perpendicular to this, so 3 times 2t minus 2 plus 2 times 4t minus 5 minus 2 times 3t is 0. So if we solve it, we get 6t minus 6 plus 8t minus 10 minus 6t is 0. So this is 60 cancelled. So this is 8t minus 16 is 0. So t is equal to 2. So since t is equals to 2, the point Q is, put t equals to 2 here, 2 to the 4 plus 1 5. This is 8 plus 3 11, and this is 6 plus 2 8, and P is 3, 8, 2. So length is PQ, it is equals to 2 square plus 3 square plus 6 square under root 4 plus 9 plus 36 under root, that is 13 plus 36 is 49, so it is 7. So this was question number 6. Now let's move on to question number 7. Question number 7. So this is from JEE 07 paper 2. So this is an assertion reason. Consider the planes 3x minus 6y minus 2z is equals to 15 and 2x plus y minus 2z is equals to 5. Statement 1 says parametric equation of line of intersection of planes is x equals to 3 plus 14t, y equals to 1 plus 2t, and z is equals to 15t. Statement 2, vector 14 I cap plus 2 j cap plus 15 k cap is parallel to the line of intersection of given planes. So first is statement 1 is true, statement 2 is true, statement 1 is correct reason for statement 2. Second is statement 1 is true, statement 2 is true, statement 1 is incorrect reason for statement 2. C is statement 1 is true, statement 2 is false, and D is statement 1 is false, statement 2 is true. Okay, so let's solve this question very systematically. I'm rubbing these. So let's first of all see statement 2. So vector which is parallel to the line of intersection will be perpendicular to the normal of both the planes. So we get n1 cross n2. So this is I cap, j cap, k cap. n1 is 3 comma minus 6 comma minus 2, n2 is 2 comma 1 comma minus 2. So this is I cap. Minus 6 minus 2 is 40 is 12 plus 2 is 14 minus j cap. Minus 6 plus 4 is minus 2 plus k cap. 3 plus 12 is 15. So we can directly see this is the same vector which is written here. So the second statement is true. Now let's see statement 1. There is also objective technique to check statement 1, but we'll do it systematically. Or let's see, suppose we assume that z equals to 15t is correct, then 3x minus 6y minus z is 15t, so this is 30t is equals to 15, and second is 2x plus y minus 30t is 5. Now let's subtract these two equations, or let's multiply this equation by 6. So this is 12x plus 6y minus 180t is equals to 30. So these two equations, let's add them. So we get 15x minus 210t is 45. So it gives x minus 15 ones are 15, 15 4 is a 60, t is 3. So x is 3 plus 14t. Now let's see y. So 2x plus y minus 30t is 5. So put x as 3 plus 14t, so 6 plus 28t plus y minus 30t is 5. So this gives y as 5 minus 6 is minus 1. This is minus 2, so plus 2t. This is 2t minus 1, and here it is written as 2t plus 1, so this is the error. So statement 1 is false. So the answer is D, that is statement 1 is false and statement 2 is true. Now let's move on to question number 8. So this is also from JEE 08. So this is basically a comprehension. So I'll write it as a comprehension. L1 is, there are two lines. L1 is x plus 1 by 3 equals to y plus 2 by 1 is equals to z plus 1 by 2, and L2 is x minus 2 by 1 is y plus 2 by 2 is z minus 3 by 3. So let's see the comprehension. Question number 8, which is unit vector perpendicular to both L1 and L2 is, options are A minus I cap plus 7 j cap plus 7 k cap upon root 99, B is minus I cap plus minus 7 j cap plus 5 k cap upon 5 root 3, C is minus I cap plus 7 j cap plus 5 k cap upon 5 root 3, and D is 7 I cap minus 7 j cap minus k cap upon root 19. So let's solve it. We have to find the unit vector which is perpendicular to both L1 and L2. So the vector which is perpendicular to both L1 and L2 is the cross product of the direction vectors of these two lines. So this is I cap, j cap, k cap, 3, 1, 2, 1, 2, 3. So this is I cap, 3 minus 4 is minus 1, minus j cap, 9 minus 2 is 7, plus k cap, 6 minus 1 is 5. So this is minus I cap minus 7 j cap plus 5 k cap, and to find the unit vector, the modulus of this vector is 1 square plus 7 square plus 5 square under root, which is 49, plus 25, which is 74, plus 1 is 75. So this is 5 root 3. So this is the answer. Okay, so now let's move on to question number 9. So this is part of the same comprehension. We have to find distance of point 1 comma 1 comma 1 from the plane passing through point -1 comma 2 comma -1 and whose normal is perpendicular to L1 and L2. So the options are 2 by root 75, 7 by root 75, 13 by root 75, 23 by root 75. Fine. So if we have a point through which the plane passing, if we have the normal to the plane, then the equation of the plane can be found. So normal to the plane is the cross product of these two vectors. So I cap, j cap, k cap, 3, 1, 2, 1, 2, 3. So this is I cap, 3 minus 4. This is 3 minus 4 is -1. Then minus j cap, 9 minus 2 is 7, plus k cap, 6 minus 1 is 5. So 3 minus 4 is -1, 9 minus 2 is 7, and 6 minus 1 is 5. So normal, the equation of the plane is -1 x plus 1 minus 7 y minus 2 plus 5 z plus 1 is 0. So this is x plus 1 plus 7y minus 14 minus 5z minus 5 is 0. So this is the equation of the plane, and we have to find the distance of this point. So distance can be directly found by the formula. So put 1 comma 1 here. So 1 plus 1 is 2, plus 7 is 9, minus 14 is minus 5, minus 5 again is minus 10, and again minus 5 is minus 15. 2 plus 7, 9, minus 14, minus 5, and minus 10 is minus 15, divided by 1 square plus 7 square plus 5 square. So this is 15 divided by 49, plus 1 is 50, plus 75. So this is 15 by 5 root 3. I think I've made a mistake. So this is, let us find the equation of the plane again. So this is the unit vector perpendicular to the plane was minus I cap minus 7j cap plus 5k cap. This was the vector perpendicular to the plane, and so whose normal is perpendicular to L1 and L2. Oh, we have made a mistake. So this was a common mistake I have done. Let's take care of it. So the normal to the plane is perpendicular to L1 and L2. So here I have done that I have taken the normal as L1 and L2, but normal is perpendicular to both L1 and L2. So normal is perpendicular to both L1 and L2. So L1 cross L2 gives me a vector which is perpendicular to both L1 and L2, and that is along the normal. So this is, I think, correct. So let us again find the equation of the plane. So this is minus 1 times x plus 1 minus 7 times y minus 2 plus 5 times z plus 1 is 0. So this is minus x minus 1 minus 7y plus 14 plus 5z plus 5 is 0. So putting 1 comma 1 comma 1 here, let's simplify it. So this is minus x minus 7y plus 5z. Minus 1 plus 14 is 13 plus 5 is 18 is 0. So putting 1 comma 1 comma 1 here, we get minus 1, minus 7 is minus 8 plus 5, minus 8 plus 5, minus 7, minus 1 minus 7 is minus 8 plus 5 is minus 3 plus 18 is 15 divided by root 75. So I think there is a mistake. I'm sorry, this was 15. So I'm sorry, the option was 15 by root 75, so this is the correct answer. So this was now from JEE 09, question number 10th. So lines with direction cosines positive through P 2 comma minus 1 comma 2 makes equal angle with coordinate axis. Equal angles with coordinate axis. The line meets the plane (2x plus y plus z equals to 9) at Q. PQ is 1 root 2 root 3 and 2. So equal angles with coordinate axis, so cos alpha, cos, so the direction cosines are all equal. So L square plus M square plus N square is 1. These all three are equal, so 3L square is 1. So L is 1 by root 3 plus minus, since angles are positive, so L equals to M equals to N equals to 1 by root 3. So this line meets the plane this. So line is x minus 2 by 1 by root 3 equals to y plus 1 by 1 by root 3 equals to z minus 2 by 1 by root 3, and this meets the plane 2x plus y plus z equals to 9. So any point on this line is t by root 3 plus 2, t by root 3 minus 1, and t by root 3 plus 2. So putting this here, I get 2t by root 3 plus 4 plus t by root 3 minus 1 plus t by root 3 plus 2 equals to 9. So this gives 2 plus 2, 4t by root 3. 4 minus 1 is 3 plus 2, 5, and 9 minus 5 is 4. So this gives t is root 3. So Q is, put root 3 here, 3, 0, 3. So PQ is 2 minus 3, 1 square, plus 1 square, plus 1 square. So it is root 3. Fine. So let's move to question number 11. So this is from JEE 2010. Distance between the planes ax minus 2y plus z equals to d, and plane containing lines x minus 1 divided by 2 equals to y minus 2 divided by 3 equals to z minus 3 divided by 4, and x minus 2 divided by 3 equals to y minus 3 divided by 4 equals to z minus 4 divided by 5 is root 6 then mod b equals to what? So we have been given the distance between two planes. We have to find the value of modulus of d. Okay, so if we have to find the distance between two planes, if the distance between two planes is not 0, then both the planes should be perpendicular to each other. Okay, so this is the plane which is containing the lines. So if I find the normal to this plane, the normal to this plane also should be parallel to it. So let's find the normal of the second plane. So this is I cap, j cap, 2, 3, 4, 3, 4, 5. 3 5 is 15, minus 16 is minus 1, minus j cap, 10 minus 12 minus 2 plus k cap, 8 minus 9 is minus 1. So this is minus I cap plus 2 j cap minus k cap. So this plane should also be parallel to this plane. First of all, let's find the equation of the second plane. So P2 is, it contains the point 1, 2, 3. So minus 1 times x minus 1 plus 2 times y minus 2 minus 1 times z minus 3 is equals to 0. So this is x minus 1 minus 2y plus 4, x minus 1 minus 2y plus 4 plus z minus 3 equals to 0. Now this plane and this plane, let's write it in proper format. X minus 2y plus z, it is minus 1 plus 4 is minus 3, minus 1 plus 4 is 3, 3 minus 3 is 0, so this is 0. Okay, so this is the plane which is passing through origin, and this is our plane P1, which was ax minus 2y plus z is d. So these two planes should be perpendicular if the distance between them is not 0. So a is equals to 1. So putting 1 here, x minus 2y plus z is d. So writing in format 1 square plus 2 square plus 1 square, 1 square plus 2 square is root 6 minus 2 by root 6 plus 1 upon root 6. So this is in proper format. So the perpendicular distance of this plane from the origin is d by root 6, and perpendicular distance of this plane from origin is 0. So root 6, so d by root 6 is root 6. So value of d is 6. Now let's move on to question number 12. This is from AIEEE 03. Lines x minus 2 by 1 equals to y minus 3 by 1 equals to z minus 4 by minus k, and x minus 1 by k equals to y minus 4 by 2 equals to z minus 5 by 1 are coplanar. A, k is 0 comma minus 1, b is k is 1 comma minus 1, c is k is 0 comma minus 3, d is k is 3 comma minus 3. So these are the two lines. This line is passing through a point 2 comma 3 comma 4. This line is passing through 1 comma 4 comma 5. So this vector, this vector is I cap plus j cap minus k cap. and this vector is k I cap plus 2 j cap plus k cap. So these three vectors, and this vector is I cap minus j cap minus k cap. These three vectors are coplanar. Then the box product of these three vectors is 0. So one is 1, 1 minus k, one is k, 2, 1, and one is 1 minus 1 minus 1 is 0. So if we solve it, minus 2 plus 1 is minus 1, minus 1 minus k minus 1 minus k minus k minus 2. So 1 minus 2 plus 1 is minus 1 minus 1 minus k minus 1 minus k minus k minus 2 is 0 minus 1. So this is plus k plus 1, this is plus k square plus 2k is 0. So this is k square plus 3k is 0. So k into k plus 3 is 0. So k is either 0 or k is minus 3. So this is the answer. Question number 13. This is from AIEEE 2011. This year AIEEE. So distance of point P 1, minus 5, 9 from plane x minus y plus z equals to 5 measured along line x equals to y equals to z is 10 root 3, 5 root 3, 3 root 10, 3 root 5. So we have to find the distance of this point from this given plane and measured along line this. Okay, so the line will be x minus 1 by 1 equals to y plus 5 by 1 equals to z minus 9 by 1. So any point on this line is, say q is t plus 1, t minus 5 and t plus 9, and this point lies on the plane. So x minus y plus z is equals to 5. X is t plus 1 minus t plus 5 plus t plus 9 equals to 5. T and t cancel. So t 1 and 5 is 6 and 9 and 6 is 15. 6, 15 is equals to 5. So t is equals to minus 10. So we get q and we have to find the distance. So q is, put t minus 10 plus 1 is minus 9. Minus 10 and minus 5 is minus 15. Minus 10 plus 9 is minus 1 and p is 1 comma minus 5 comma 9. So distance is 10 square plus 10 square plus 10 square. So this is 10 root 3. Now let's move on to question number 14. So a variable line has direction cosines in two positions as L, M and N, L plus del L, M plus del M, N plus del N, show that delta theta between lines between two positions is delta theta whole square is del L square plus del M square plus del N square. So there is a variable line which is moving, and at one point its direction cosines are L, M and N, and at another point its direction cosines are L plus del L, M plus del M and N plus del N. So we have to show that the angle between these two positions, that is delta theta, del theta, is given by this formula. So how do we solve it? First of all, since both of these are direction cosines, so L square plus M square plus N square is 1, and L plus del square plus M plus del M square plus N plus del N square is 1. So this gives L square plus del L square plus M square plus del M square plus N square plus del N square plus twice L del L plus M del M plus N del N is 1. Now L square plus M square plus N square is 1. 1 and 1 cancel. So we get del L square plus del M square plus del N square is minus 2 times L del L plus M del M plus N del. Okay. So now del theta between two lines is given by the dot product formula. So cos del theta is L plus del L plus M plus del M plus N plus del N. Now for small theta, it can be approximated as this. For small theta, cos theta is 1 minus theta square by 2. So this is L square plus M square plus N square plus L del L plus M del M plus N del N. So this is 1 minus del theta whole square by 2. This is 1, and this is minus times del L square plus del M square plus del N square by 2. So this gives del theta square is del L square plus del M square plus del N square. So now let's move to question number 15. So a variable plane passing through a fixed point alpha, beta, gamma meets the axis in A, B, C. Show that locus of point of intersection of planes through ABC parallel to coordinate planes is alpha x inverse plus beta y inverse plus gamma z inverse equals to 1. Okay. So let us assume that the equation of the plane is x by a plus y by b plus z by c is 1. And let the locus as coordinates h, comma k, comma l, say. This is our locus. So this plane, this is the plane which is passing through the fixed point alpha, beta and gamma. So alpha by a plus beta by b plus gamma by c is 1. Now locus of point of intersection of planes. So a plane, so the point A is, let us find point A. Point A is the point at which these planes meet the x-axis. So putting y and z as 0, we get point A as a comma 0 comma 0. Similarly, point B is 0 comma B comma 0, and point C is 0 comma 0 comma C. Now the plane through ABC, let they be P1, P2, P3. So P1 is perpendicular to the x. The P1, say P1 is perpendicular to YZ plane. So P1 has x constant, say x equals to a. Say P2 has y equals to b, and P3 has z equals to c. Now these three planes meet at a point a comma b comma c. So point of intersection is a comma b comma c, which is h comma k comma l. So replace a by h, b by k and c by l. So we get alpha by h plus beta by k plus gamma by l equals to 1. Now h, k, l are replaced by x by z. So we get, so this is our locus. So now let's take a match the column. Plane XOZ divides join of -1, 1 comma -1 comma 5 and 2 comma 3 comma 4 in lambda is to 1, lambda is algebraic sum of intercepts made by the plane x plus 3y minus 4z plus 6 equals to 0 on axis is cosine of the angle between planes 3x minus 4y plus 5z equals to 0 and 2x minus y minus 2z equals to 5 is distance of P 3,8,2 from line x minus 1 by 2 equals to y minus 3 by 4 equals to z minus 2 by 3 measured parallel to 3x plus 2y minus 2z plus 17 equals to 0. This is 7, 0, 1 by 3 and minus 13 by 2. Okay, so let's solve this, match the column. Let's solve the first part. So this plane divides the line joining this and this and ratio this and this. So let's find, so this is point 1 comma minus 1 comma 5 and this is point 2 comma 3 comma 4. The ratio lambda is to 1. So let us find this point Q. So the point Q has x coordinate as 2 lambda plus 1 divided by lambda plus 1, has y coordinate as 3 lambda minus 1 divided by lambda plus 1 and z coordinate as 4 lambda plus 5 divided by lambda plus 1. Now this point lies on the XOZ plane. XOZ plane is basically that plane on which y is equals to 0. So y is equals to 0. So 3 lambda minus 1 divided by lambda plus 1 is 0, implies lambda is 1 by 3. So A is matched to 1 by 3. Now let's go to second part, B. Okay, so algebraic sum of the intercepts made by the plane on the axis. X, the plane is x plus 3y minus 4z plus 6 is 0. So x plus, so this is minus x minus 3y plus 4z is equals to 6. So minus x by 6 minus y by 2 plus z by 3 by 2 is 0. So this is the general form of the equation, like x by a plus y by b plus z by c equals to 1, where a by c are x, y are the intercepts on x, y and z axis. So intercepts are minus 6, minus 2 and 3 by 2. So their sum is minus 8 plus 3 by 2, which is 2, minus 16 plus 3, it's minus 13 by 2. So this is minus 13 by 2. So now let's see the C part. Cosine of the angle between the planes. Angle between the planes is angle between their normals. So let's write the normal vectors. 3 I cap minus 4 j cap plus 5 k cap and 2 I cap minus j cap minus 2 k cap. So angle is 9 plus 16 plus 25, 4 plus 1 plus 4 cos theta is 3 to the 6 plus 4 minus 10. So cos theta is 0. So this is 0. Now let's move to the D part. We have to find the distance of this point from the line this measured parallel to this plane. So any point on this line can be written as, say Q can be written as 2t plus 1, 4t plus 3 and 3t plus 2. 2t plus 1, 4t plus 3 and 3t plus 2. So the line joining P and Q is parallel to the plane, that is, it is normal, it is perpendicular to the normal to the plane. So PQ has direction ratios 2t plus 1 minus 3. So this is 2t minus 2. 4t plus 3 minus 8, this is 4t minus 5. 3t plus 2 minus 2, that is 3t. And it is perpendicular to this plane. So 3 times 2t minus 2 plus 2 times 4t minus 5 plus minus 2 times 3t is 0. So 6t plus 8t minus 6t minus 6 minus 10 is 0. So t is 2. So q is 5, 15, 8 and p is 3, 8, 2. So distance is 5 minus 3, 4, 749 plus 36. There is some mistake out there. Q is 2 to the 4 plus 1, 5, 4 to the 8 plus 3, it's 11, sorry, it's 11 and this is 8, this is 3, 8, 2. So distance is 5 minus 3, 2, 2 square is 4, 11 minus 8, 3, 3 square is 9, 8 minus 2 is 6, 36. So this is 7. Okay, so this is the entire match the column done. So I think I've covered the basic questions which are important for 3D geometry. If there are any problem, you can get back to us. Thank you.